All right, so we're going to look at some graphs of secant and cosecant. This is an example video, so I have a lesson video where I break down all the steps in like much slower detail, and then in this video I'm just going to like go through all these examples. So if there's a particular one that you want to see, you can just, forward to that example. Otherwise, I'm going to go through these four. So let's get to it. So starting with the first one, I've got y equals -2 secant x plus 3 pi over 4. So in my lesson video, I talked about that the big thing you need to do first with these is you really want to find the guide function. And so to do that, you just think about secant is the reciprocal of what? It's just the reciprocal of cosine. And so that is your guide function. So 2 cosine. So you just like rewrite the whole function and just replace secant with cosine. And so now I'm going to go through all the work to graph actually the guide function, because if I do that, then I will get the graph of secant kind of for free. So I need to figure out what is my period. In this case, my period is 2 pi, which means that the steps that I'm going to take on my table will be pi over 2 in size. And then for my start and my end, so what I'm going to do is I'm going to take this x plus 3 pi over 4, and I'm going to wedge that in between one period, and then I'm going to figure out, I'm going to solve for x so I can figure out where my starting point should go. So I can subtract off the 3 pi over 4, like so. And, okay, so then this comes out to 5 pi over 4. Okay. So this is where I want to start my table, and if I do it right with my steps, this should be where my table ends. So you'll notice that I do everything now in gold. This is just so that I remember that I'm working with the guide function. So we're going to start at that -3 pi over 4, and I just want to figure out what my x value should be, because then my y values I can figure out no problem. So remember, my steps are going to be of size pi over 2. So pi over 2 steps, that's equivalent to, maybe I'll write it over here, 2 pi over 4. So just reminding myself of that when I start adding. So if I start adding 2 pi over 4 to this will become -pi over 4, pi over 4. Let's see, let me fix this line here. And then 3 pi over 4, and then 5 pi over 4. And wasn't that, oh yes, that is what I wanted for my end. Okay, so I've got all my x values, so now I can just finish this table. So I can plug in some values for y. So I'm going to have -2 cosine of -3 pi over 4 plus 3 pi over 4. So I can see that that's going to give me cosine of 0. Cosine of 0 is equal to 1, so this will all equal -2. And then I can move on to -2 cosine of, let's see, -pi over 4 plus 3 pi over 4. So this is going to give me -2 times cosine of pi over 2, which is 0. So this whole thing will equal 0. And then I can move on to -2 pi over 4 plus 3 pi over 4. So this is going to, oh, sorry, this is supposed to be cosine. Cosine. -2 cosine of pi over 4 plus 3 pi over 4. So this gives me cosine of pi, which is -1. So -1 times -2 will give me +2. And then if I just continue on here, I'll get 0 and -2. So you can check the math just to be sure of that. But now I have all the points that I need so I can actually graph my guide function. So let's go and let's make some space. So remember, we're ultimately trying to graph this. I put this all in a different color just so I wouldn't forget that this is the guide function. So now I can set up my graph. Let's see, I need to center this y a little better. Okay, so we'll go in pi over 2 intervals. I think that'll work. Can I get by? I think I can get by with 3 pi over 2. Yeah, that'll work. And then -pi over 2, -pi, and then -3 pi over 2. Okay, so now I can go ahead and graph my guide function. So remember, it is a guide function. Okay, so negative, oops, and I need my y coordinates. Boop, 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 boop. Okay, so now I have this point here, and then I'll come here. Here's where negative pi over 4 is. And then here's pi over 4. And then 3 pi over 4 is going to be here, so it's going to be back to 0, and then here. So I'm graphing actually all the points in between all the coordinates. So maybe you wanted to choose a different axis. That's totally okay. Okay, so I'm going to go ahead and connect these. Now, the one thing I recommend when you connect these is that you make a dotted line so that you remember this is the guide function. And you know what, I'm going to continue this pattern out a little bit just to help me graph a little bit more. So I'll just keep going this way. And we'll go off into the distance, into the sunset, and then we'll go this way. Okay, so there's my graph of cosine. Now, how do I actually graph secant? Right, wasn't that the whole point? Okay, so this is a guide function. So now what you're going to do, where you see the x-axis, that actually represents your asymptotes for secant. So now I can go ahead and all the places where I see the x-axis having these intercepts, like you see here, you can see how I'm just putting in these asymptotes. All right. So now I've got my asymptotes, and then basically, like, we're basically done, because now this represents the top of, let's see, this represents the top of this part of the function, and then this will represent the bottom of this part of the function. And so you just want to be careful when you draw these to make sure that they don't look like they're going to cross the asymptotes. There you go. And so the white part is the graph of secant. So that's how that works. Okay, so moving on to 1/2 cosecant 2x minus pi. So of course we want to find the guide function first. And so cosecant is the reciprocal of sine. So I just replace cosecant with sine. And so now I want to go through all the work to really graph sine. So my period in this case is going to be, so I take 2 pi and then I divide it by 2 to get pi. So the steps that I'm going to take then, I will just divide that by 4. So I want to take pi over 4 steps. And now I need to think about the start and the finish. So I start with the typical period of sine, and I take what's in the sine function, and this will allow me to adjust what the normal period would have been, so that now we can adjust it to our function. So I add pi to each side, and so then let's see, that gives me 2 pi minus pi, or plus pi is 3 pi. Okay, good, I can do that. And then I divide all sides by 2 to get pi over 2, if I could write. And then 3 pi over 2. So here's where I want to start, and if I do it right, here's where I should end. Okay, so I've got everything in gold here. Oops, and I had some scratch work from earlier. Okay, so I'm going to start at pi over 2, and so let's go ahead and do our pi over 4 steps. So remember, pi over 2 is the equivalent to 2 pi over 4, so I just write that out so that it helps me with my steps. So if I add pi over 4 to this, I will get 3 pi over 4. If I add pi over 4 to that, I get pi, and then I get 5 pi over 4, and then if I add that, I get 6 pi over 4, which will simplify to 3 pi over 2, which was what we were hoping the end would be, right? Okay, so I can get rid of all this stuff, and now we can start plugging stuff in. So you probably know like how these values that you get, oops, if I remember the sine function, what these values inside these trig functions are. Oh my God, I'm on the struggle bus here, guys. Okay, so, all right, I plug this in and I get pi minus pi, so this starts out as sine of 0. So, you know, we've seen this pattern of the things that you plug in, they kind of work out into a certain pattern over and over. So sine of 0 is equal to 0, so this will be 0, and then I've got 1/2 sine 2 times 3 pi over 4 minus pi. So this is 1/2 sine of, what is that, 3 pi over 2 minus pi. So this comes out to 1/2 sine of half pi, so that's 1, and then I multiply that by 1/2, so this will be equal to 1/2. And then I've got half sine of 2 pi minus pi, so sine of pi is going to be equal to 0, so this is 0. And then as I continue on, I'll get that this is negative 1/2 and this is 0. So you can confirm the math. Okay, so now we are ready to graph, so let's make some space. Okay, so let's see. For my axes, I'm going to have everything just be positive. So there's my y-axis, there's my x-axis, and I will go, why don't I go in pi over 2 steps. So 3 pi over 2. Let's see, is that going to do it for me? Yeah, that'll work out just fine. Okay, so, all right, I've got that. This is going to represent 1/2. This will represent negative 1/2. So remember, I want to use a different color just to help create my guide function. So I start at pi over 2, 0, so right there. Then I've got 3 pi over 4, so and 1/2, so it's going to be here. And then pi 0, and then 5 pi over 4 is going to be here, and then 3 pi over 2 goes back to 0. Okay, so I like to use a dotted line so that I use this really as a guide. So here's my function. Now I also like to continue the pattern if it's easy enough, which in this case I think it is. So I'm just going to go ahead and continue the pattern. So I just like having a nice full looking function. We only needed to do this over one period, but this will work. Okay, so in this case now, I have everything I need to graph the function that I wanted to graph. So where I have my x-intercepts, those are going to represent my asymptotes. So I have one here, I have one here, I have one here, here, and here. So those are my asymptotes. And then these points are really representing the kind of those different U-shaped graphs. So I have one going this way, and this way, this way, bink, 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 boom, there we go. So there is your graph of 1/2 cosecant 2x minus pi. Okay, so now let's move on to something that gets a little more challenging. So I've got 2 plus cosecant 1/2 x plus pi. So what's going to make this kind of weird is this 2. It's actually going to move what we think of as our line for like where our asymptotes hit. So I'll talk about that more when we get to that point. So just to start, we're going to come up with our guide functions. Remember, cosecant and sine, those are reciprocals of one another. So I'm going to go ahead and just replace cosecant with sine, and I'm just going to do all the work to graph this new guide function. So my period in this case is going to be 2 pi divided by 1/2. So that's 2 pi divided by 1/2, so that's 2 pi times 2. So my period in this case is 4 pi. So the steps that I'm going to take are going to be 4 pi divided by 4, so nice whole number of pi steps. And then to figure out where my start and end is, I take the part that's inside the sine function and I wedge it between 0 and 2 pi, and then I solve. So I can just go through all that, multiply all sides by 2 to get negative 2 pi is less than or equal to x is less than or equal to 2 pi. So great news, setting up the table for this one will be much simpler. Okay, so I need to start at negative 2 pi, and then remember I'm taking pi steps, so thankfully the math here is going to be nice and straightforward. So this will be negative pi, 0, pi, and 2 pi, which was exactly where we wanted to end, right? Okay, so now I can just start kind of plugging things in. So I've got 2 plus sine of 1/2 times negative 2 pi plus pi. So this is going to end up giving me sine of 0, and I know that sine of 0 is equal to 0. However, don't forget about that 2. So first point here is going to be 2. And then I plug in negative pi. So let's see, I'll just write this as negative pi over 2 plus pi. So this becomes sine of pi over 2, which is equal to 1. So this is going to be 2 plus 1, so this equals 3. So you'll notice that this 2, as we would expect, the sine function normally starts at 0, but because we have this plus 2, everything's being moved up. So it's just important to kind of recognize that from when we get to the actual graphing stage. And then I'll just do one more of these. So if I have sine of 0 plus pi, so sine of pi is just equal to 0. So then I have, once again, 2 plus 0. So this will equal 2. And let's see, do I want to do the next one? I will just go ahead and say then for this next one, so then you're going to end up getting negative 1. So negative 1 plus 2 will give you 1, and then we come back up to 2 here. Okay, so now we can graph. So let's go ahead and set that up. So let's set up our graph. And in this case, I will just go in quantities of pi. Oops, and this should be negative pi and negative 2 pi. And then 1, 2, 3, 1, 2, 3. Okay, so now we can start plotting points. So remember, I like to plot in a different color. So I've got negative 2 pi 2. And then negative pi 3, 0, 2, pi 1, and then 2 pi 2. So I'll just make my little dotted guided line. Okay, and so there's a big hint here of what you have to do next, because it might feel like, oh, I'm going to forget what I have to do next. So, all right, normally you would look at where your x-intercepts are, and then that would be where your asymptotes are for your guide function. However, we don't have any x-intercepts here. And if you go back and look at the function, that's because this function was moved up by 2. So this line here, the x-axis, this used to be what we thought of as the asymptote cutoff line. And now that has moved, this 2 plus has moved that asymptote cutoff line up by 2. So what I'm going to do is I'm just going to draw the new asymptote cutoff line. So the places where my asymptotes are going to fall now are any place where I intercept with that cutoff line. So just to be clear, here, here, and here, okay? All right, so let's get rid of that. So now I can draw in my asymptotes. So right here, and right here. And so now I'm in the home stretch, right? So now I can just finish off my graph. So I'm going to have, here's part of it. I did not quite get my scale too beautiful, so it looks a little off scale here. But there are the two pieces of my graph. So there is my graph of cosecant. Okay, and so for the last one, I've got 2 minus secant 2 pi x minus pi over 2. So we've got kind of the whole shebang. We've got a lot of stuff going on with this one. So my guide function is going to be 2 minus 3 cosine 2 pi x minus pi over 2. Now, you know me, I always say the math is not a spectator sport. If you are watching this because you're trying to learn how to do this, I think this is an awesome one after the last 3 that we've talked about. I think this is a good one to pause, try it yourself. You'll get a lot more out of this video if you try it yourself and then watch the explanation. Okay, so the period in this case, take 2 pi divided by 2 pi, that just equals 1. So my steps in this case are just going to be 1/4 in size. And then for my start and end, so I'll take that 2 pi x minus pi over 2 and wedge it between 0 and 2 pi. So I just got to solve for x now. So this becomes pi over 2 is less than or equal to 2 pi x. And then let's see, this is 4 pi over 2, so this becomes 5 pi over 2. And then I divide everything by 2 pi. So when I do that, this becomes 1/4 is less than or equal to x, and that's going to be less than or equal to 5/4. So the pi's drop out. Okay, so now I can set up my table. Okay, so I'm going to start at 1/4, and remember that the steps I'm taking are 1/4 in size, so at least it's going to be easy to figure out the steps here. This just becomes 1/2, 3/4, 1, and then 5/4, which is what we wanted for our end. And then I can start plugging stuff in. Okay, so this becomes pi over 2 minus pi over 2 when I plug in pi over 4. So I get cosine of 0. So cosine of 0 I know is equal to 1. So this will equal 2 minus 3. So this will equal -1. And then I've got 1/2. So this becomes 2 minus 3 cosine. So this becomes pi minus pi over 2. And so cosine of pi over 2 is equal to 0. So this is just going to be 2 minus 0. So this will be 2. And then I've got 2 minus 3 cosine of, let's see, what does this work out to? Pi over, so if I multiply 2 pi times 3/4, that comes out to 3 pi over 2, sorry. Having a brain moment there. So this comes out to cosine of pi. So cosine of pi is -1, so this becomes 2 times -3 times -1. So this is going to be 2 plus 3. So this is equal to 5. Okay, and so if I were to continue on with this, so the last values that I'm going to get are 2 and then -1. Okay, so we've got all of our points. So now we can graph. Okay, so let's set up my graph. So let's see, what axes do I want to use? I'll go with all positives here, and I'll just go 1/4, 1/2, 3/4, 1 and 5/4, and then 1, 2, 3, 4, 5, -1, 2, 3, 4, 5, and so I can start plotting my points. So again, I like to use a different color. So let's see, I start here at -1, 1/2, 2, 3/4, I'm going to go up to 5, come back down to 1, and then back to -1. And if I wanted to, I'll just graph this for right now. Okay, so I connect all of this, and so now we've got to talk once again. So this one can seem a little deceptive because it looks like I have x-intercepts, but you have to take a moment to remember that this function has been moved up 2. So that asymptote cutoff line actually needs to be moved up 2 once again. So sometimes you might still have asymptotes, and so then you have to remember to look at your function. And so my asymptotes will be here and here. Okay, so now I'm going to go ahead and draw in those asymptotes, and then here's let's see, this will be another asymptote, I guess, right here if I continue the pattern. So this will be one part of the function, here's the next part, and here's the last part. And so there's the graph. Okay, and so that brings us to the end of this video. So hopefully that was helpful and helped you wrap your mind around these functions. So thanks for watching, guys. I will catch you next time.